Artificial intelligence, AI, is no longer a futuristic fantasy. It's woven into the fabric of our daily lives, from the recommendations on our streaming services to the voice assistants in our homes. But how does this seemingly magical technology actually work? The answer, while complex, can be broken down into a fascinating journey through data, algorithms, and a touch of simulated intelligence. At its core, AI aims to mimic human cognitive functions, such as learning, problem-solving, and decision-making. This is achieved through a variety of techniques, the most prevalent of which is machine learning. Imagine teaching a child to identify a cat. You might show them numerous pictures, pointing out the defining characteristics: pointy ears, whiskers, a furry tail. Machine learning operates similarly. Instead of explicit programming, algorithms are trained on vast datasets, allowing them to identify patterns and make predictions. For example, an AI trained on millions of cat images can learn to recognize a cat in a new image, even if it's in a different pose or lighting. This learning process relies heavily on data. The more data an AI system is fed, the more accurate and nuanced its understanding becomes. This data can be anything from text and images to sensor readings and financial transactions. The quality and diversity of the data are crucial, as biased or incomplete data can lead to flawed outcomes. Think of it like a chef trying to create a delicious dish with spoiled ingredients. The result won't be palatable. Within machine learning, several approaches exist. Supervised learning involves training an algorithm on labeled data, where the desired output is known. For instance, in our cat example, the images would be labeled cat or not cat. Unsupervised learning, on the other hand, deals with unlabeled data, allowing the algorithm to discover patterns and relationships on its own. This is akin to giving a child a box of Legos without instructions and letting them explore and create. Reinforcement learning takes a different approach, rewarding desired behaviors and penalizing undesired ones, much like training a pet. This technique is particularly useful in robotics and game playing. Another key component of AI is deep learning, a subfield of machine learning that utilizes artificial neural networks. These networks are inspired by the structure of the human brain, consisting of interconnected nodes organized in layers. Each connection has a weight, which represents its strength. As data flows through the network, these weights are adjusted, allowing the network to learn complex patterns. Deep learning has revolutionized areas like image recognition, natural language processing, and speech recognition, enabling AI systems to achieve human-level or even superhuman performance in specific tasks. But AI is not just about crunching numbers and recognizing patterns. It also involves representing knowledge and reasoning. Knowledge representation techniques allow AI systems to store and manipulate information about the world, enabling them to answer questions, draw inferences, and make decisions. For example, an AI-powered medical diagnosis system might use a knowledge base of symptoms, diseases, and treatments to suggest a diagnosis based on a patient's symptoms. The journey of AI is far from over. Researchers are constantly exploring new techniques and pushing the boundaries of what's possible. Areas like explainable AI, XAI, aim to make AI decision-making more transparent and understandable, while other researchers are focusing on developing more robust and generalizable AI systems that can adapt to new situations and learn continuously. As AI continues to evolve, it promises to transform industries, revolutionize scientific discovery, and reshape our world in profound ways.
Thanks for your watching. Please hit the subscribe button and ring the bell for more interesting videos next time.